Now we'll be talking about the change of subject of formula. And what do we mean by that? Sometimes the unknown variable in a formula or equation is not the subject, so we need to change it to the subject so that we can solve for it. What do I mean by that? So if you recall our formula for simple interest, which was given as, or which is given as the principal times the rate times time over 100, you can see that the simple interest is written in terms of the principal and rate and time. So therefore we say that the simple interest is the subject of this formula, because all other variables are written so that they will represent the simple interest. So how about a question in which I know the simple interest, I know the principal and I know the time, but I'm asked to find the rate. So in this case I need to make the rate the subject of formula. So to make a variable the subject of a formula, what it means is to make the desired variable on one side of the equal sign, while the other variables will be on the other side of the equal sign. So if I want to make r the subject of formula, I need to take this r to be in one side and the other variables will be at the other side of the equal sign. So in this case, how would I go about this? You know that first I will need to cross multiply. So I will have my principal times rate times time is equals to the simple interest times 100. And if I divide both sides by the principal and the time, P and T cut, so I have what? I have my rate is equals to what? The simple interest times 100 over my principal times time. So as you can see now, I've written the rate R in terms of the simple interest, the principal and the time. So the rate now is the subject of formula. So how do we go about making a variable the subject of formula? So all you have to do is just your normal simple algebra, and by algebra I mean that you can perform any arithmetic operation provided what you do to the left hand side of the equal sign you also do on the right hand side. So for example, if I say speed is equals to distance over time, and I want to make the distance the subject of formula, so what do I have to do? I have to multiply both sides by the time. So if I multiply both sides by the time and I multiply here by the time, so as you can see this time will cancel out, so I have what? My distance is equals to what? My speed times time. So what this means is that you can perform any operation. Just put at the back of your mind that anything you do to the left hand side of the equal sign, you must also do to the right hand side of the equal sign. So let's look at some examples. So firstly, we are told to make x the subject of formula in this expression here. So how do we go about this? We are told that a is equals to b plus x over b minus x. So what's the first thing we need to do? We need to make sure that only x is in one side of the equation, and the first thing we have to do is we can multiply both sides by b minus x. So if we multiply both sides by b minus x and I multiply this side also by b minus x, that this we cancel this, so I'm left with a into bracket b minus x is equals to b plus x. So if you will notice, this expression here is the same thing that I've gotten when we say cross multiply. So sometimes we just cross multiply without knowing what it means. So when we cross multiply, we see that we have a into bracket b minus x being equals to what? B plus x. So when you are cross multiplying, what you are doing in essence is that you are multiplying the left hand side of the equation by the denominator of the right hand side. I am multiplying the right hand side by the denominator of the left hand side, which is what we have done here. So now we can expand this. So we have ab minus ax is equals to b plus x, but our goal is to make x the subject, so we have to bring and collect like times. So this time has x and this time has x, so we'll bring this over here and we'll bring this over here. So what I mean by that is we will subtract b from both sides. So if we subtract b from both sides, I have ab minus b minus ax. If I subtract b from this side, then this b comes out, so I have only x. And if I add ax to both sides, I have ab minus b minus ax plus ax is equals to x plus ax. So this cancel this. So I'm left with what? I'm left with x plus ax is equals to ab minus b. Then I can factorize. X is common to both of them, so I have x into bracket. And what am I left with here? I'm left with 1 plus a. Similarly, b is common to this side, and I'm left with what? A minus a. So if I divide both sides now by 1 plus a, and I divide both sides by 1 plus a, then I'm left with what? X to be equals to b into bracket a minus 1 over 1 plus a. So as you can see now, you have only x on the left hand side and all other variables on the right hand side. So I've made x in this case the subject of the formula. So let's take a look at another example. So in this example, we are told that the period of a compound pendulum is given by t, and it is equals to the square root of h squared plus k squared over gh. Then we are now told to express k in terms of t, h and g. So now we are given t as the subject, but we are told to make k the subject. That is what it means to express k in terms of t, h and g. So how do we go about that? So this is pretty straightforward, like we have been doing. And you have to recall, anything we do to the left hand side, you have to do to the right hand side. So to start with, let's write out the question. We have 2 is equals to 2 pi times the square root of h squared plus k squared over gh. So now, since this k squared is underneath a square root, the first thing I have to do is to remove this square root sign, and I achieve that by multiplying both, by finding the square of both sides. So if I find the square of this side and I find the square of this side, what does this side equals to? I'm left with what? T squared is equals to, what is 2 squared? 4. Pi squared will be pi squared. There's this square, will cancel this square root sign. So I'm left with what? H squared plus k squared over gh. So now, as you can see, I'm making progress. So to remove the denominator in this case now, I have to multiply both sides by gh. So if I multiply here by gh and I multiply here by gh, then this cancel this. So I'm left with what? T squared gh is equals to 4 pi squared into bracket h squared plus k squared. So now, to remove this 4 pi squared, now I can divide both sides by 4 pi squared. So if I divide both sides by 4 pi squared, what am I left with? This will cancel this. So I'm left with what? T squared gh over 4 pi squared is equals to h squared plus k squared. So what can I do now? I'm trying to make k a of formula, so I can minus h squared from both sides, or similarly, it means bringing h to this side. So I'm left with what? T squared gh over 4 pi squared, then minus h squared is equals to k squared. And to make k the square root of formula, or to remove this square sign, what do I have to do? I need to find the square root of both sides of the equation. So when I find the square root of this both sides, then this square cancel this square root. So I'm left with what? K now will be equals to the square root of what? Of t squared gh over 4 pi squared, then minus h squared. So we have expressed k in terms of t, g and h. So let's look at a final example, and this example is actually gotten from JAMB question. So this is an actual JAMB question, and I want you to pay really close attention to this. So in this case, we are told that z is equals to x squared plus 1 minus y cubed, and we are told to make y the square root of formula. So this, let's write it. So this is the same thing as saying x squared plus 1 over y cubed is equals to z. It means the same thing. So what can we do? First, we need to eliminate this x squared, and we do that by subtracting x squared from both sides of the equation. So when we subtract x squared from both sides, so if we subtract x squared, then x squared goes away from x. So we are left with 1 minus y cubed is equals to z minus x squared. Same thing as bringing x squared to this side, which now turns to a minus. So now what do I have to do now? I have to like cross multiply. So when you cross multiply in this case, you have 1 times 1. So I have y cubed times this. So I have y cubed times z minus x squared is equals to 1 times 1 is what? 1. So now I have to divide both sides by what is in this bracket, z minus x squared. So I'll be left with only y. So if I divide both sides by z minus x squared and I divide it by z minus x squared, so what am I left with now? This cancels this. So I'm left with y cubed is equals to 1 over z minus x squared. So now to find y, I have to find the cubic root of y cubed. So when I find the cubic root of both sides, I have y is equals to, then what is the cubic root of 1? Is 1. And the cubic root of the denominator will just be the cubic root of z minus x squared. So now if you remember from our law of indices, the cubic root, let's say for example, the cubic root of a number is the same thing as what? That number raised to power 1 over the root 3. So x raised to power 1 over 2 is the same thing as square root of x, and x raised to power 1 over 5 is the same thing as the fifth root of x. So in this case, cubic root of z minus x cube is the same thing as z minus x cube raised to power 1 over 3. So I can write this also as 1 over z minus x square raised to power 1 over 3. And what option corresponds to that? And that will be C. So the correct answer to this question is C. So that pretty much sums up what you need to know about change of subject or formula.